I have the honor of introducing the theme for tonight, and energy is what we'll be talking about. By 2050, transportation will become Canada's highest energy-consuming sector. Now we need to reconsider not only what modes of transportation we use, but also what kinds of energy and infrastructure that we use to fuel them and get around on. So tonight we will hear from two charrette design teams that sought to answer the following question. This is what we posed to them. How can we create a green-powered transportation system that will propel us into the future?
Hi, thanks for inviting me here. I'm happy to be here and represent my team. I mean, one of the things about a charrette, which is kind of interesting, is that I'm presenting a project that's not mine. It's a huge kind of collaboration of people that never met, most of us, when we entered the room, and had a three-day big discussion to try and solve a problem, and then we ran off and got some people to help us draw it up, and so it's been a long time, and I survived it. I'm the only one left, so that's why I'm up here. And we had a pretty challenging subject too. I shouldn't have said that I would take any of the teams that they gave me my choice at one point, and I just said, "Oh, put me on whatever you want." And our assignment was the QEW. So, and they said to make it I think they said energy producing highway, and it turned out we very quickly concluded that it would be very hard to produce more energy than it took the vehicles to move along it. But we took it in the most broadest sense of how can we minimize the amount of energy expenditure, maximize the amount of energy production, but also try and just make a sustainable and productive use of that amount of land. It's an incredible amount of land that's used for basically a monoculture. So this is kind of a picture of one piece of it's the gardener part, but of the QEW connection, and it shows you what we're doing with it right now. And this is what we came up with. So we decided if everyone just cycles between Hamilton and Toronto from now on, there'll be almost no energy spent, and it's good for your, oh no, sorry, that's another project of mine. So today we have the QEW. It's energy consuming, air pollution, waste your time, noise creating, all these terrible things that highways do because they are designed as a monocultural infrastructure that has only one use, and it's mostly petroleum-based cars that are using it today. And so we're gonna try and make it more energy producing, try and make it clean the air, save some of your time, reduce noise, and liberate the land. So when we all got in the room, we're like, well, we opened it up. We said, just because it's a highway, let's rethink the whole thing. Does it have to be a highway? Could we just go back to horse and buggy and solve a lot of the problems? And then we were like, well, we need to keep some of the convenience that we have today. So we looked at kind of the major things. And if you think about the inventions of transportation over the last 100, maybe 200 years, basically rail and asphalt are the two big infrastructural inventions of that time. And the rail are really efficient, but they have some limitations. They're station to station. You can only get on the train when the train goes. You're limited to the schedule of the train, getting enough people to fill that train to move once. You have to get to the station, so you're gonna have a centralized kind of city environment, which everyone is familiar with, the older cities in Europe especially, or Japan, where this whole city centers around that station. And they have a limited network because of the heaviness of the infrastructure and the amount of effort it takes to make the rails. It's going to be limited to corridors like that. And cars have a lot more freedom. They're door to door. This is what the American dream is, that everyone can get up and get in their garage and end up at work, and they don't have to rely on any other systems. They could basically control their world as long as those highways and roads are working properly. So you get the freedom, you get a large expansion. Some of the downsides of the cars, though, is that they're not as efficient as rail. Steel on steel, they take a lot of maintenance, highways do, salt, plowing, all the different, patching the asphalt. There's a lot of there's a lot of embodied energy to make them in the first place, and then a lot of maintenance energy to keep them going. And they rely mostly on fossil fuels, at least today. And then there's a commonality, there's a common problem to both of them in that they both, because of the size and scale and speed of these corridors and the noise, they both create barriers in our cities. That's why people want to stop highways, stop expressways from cutting through the middle of their cities. But rails have basically a similar effect, which is, you can see along the waterfront of Toronto, there's the two parallel systems are there. So right now, about 85% of the transportation in Ontario is fueled by petroleum. And so over the next, our assignment is like kind of like up to 2040-ish. Ours might not really be built till 30, 40, but we were trying to imagine a 30-year time span. So we're looking at doubling the use in the next 30 years. So right now, the average kilowatt hour per capita per day for a person in the GTA is 26.5. And there's 25 million travelers, so that's 6 million kilowatts per day. And so in 30 years, we're looking at like in the, I can't even read numbers that big, 119 million. So we were looking at a new system. And this new system, we would hope, if our calculations are correct, we're using a lot of speculative technologies, so we had to use a lot of speculative math to get to this. But with the same number of travelers, we can expand the range from 30 minutes. Right now, you can only get from Hamilton to kind of Oakville, and you should be able in the future to be able to get to Toronto in 30 minutes with using only half the amount of energy per person and going at twice the speed. So this is our goal, which isn't an energy producing highway, but it might be a lot nicer highway. So what would it be like? What would it be like if we could go twice as fast with half the energy? So here's a day. Paul gets up. He wants to go on his trip, and he plugs it into his iPhone on his balcony there. And then he automatically gets hooked into the system. We call it an MPRT system. I'm going to get to that in a second. And he gets into the MPRT system. He gets up, takes his bike, rides his bike to the station, parks it at the station, and gets into his pod. Well, he's tired when he gets up the stairs, because it's a tall set of stairs. And then within 6 minutes, he's going 200 kilometers an hour up in the air, above everything else, and arriving at Port Credit Station, where he gets off and connects to his bus connection. And so we're calling this a MPRT system. We call it multimodal personal rapid transit. And personal rapid transit is a technology that we did not invent, and many people are working on it. And it's kind of like a rail-based system, like a monorail up in the air, but each vehicle is its own pod, and these pods are almost like horizontal elevators. You can type in where you want to go, and it will take you there. And they group up and form a train at times. So you can see there's a row of them there in the right-hand corner, and get up to train speed, basically. And then as they get closer to their destinations, they split off, and everyone gets delivered to where they want to get delivered. So it's a kind of smart system, computer-controlled, that's taking you from almost door to door. And the typical PRT system is the diagram is on the top, which is most of the kind of space age imaginings of a PRT system is kind of like this complete total network that you can go door to door right from your house almost, and you hook yourself onto this coat hanger and you go through the dry cleaning machine, you end up where you want to end up. And we were thinking, like, it sounds really convenient, but a little not very civilized. So we thought, how could this really work better? And this is what this I think, to my mind, this is kind of the biggest idea that came out of the charrette, which was to say, maybe we should use it more like a train. We'll compress that PRT system into a corridor and use it to deliver people across a linear corridor quickly without having to take it to everybody's suburban door. So you save a lot of money on the infrastructure investment up front, but you get a lot of the solution that takes you between the personal vehicle and a train system. And one of the nice things is you can connect into all the other modes of transportation which allows people the flexibility and choice of using active transportation, their car, the PRT, the train for long distances. It's a parallel system, so it's adding another advantage to systems that are already working. So it's also easier to implement in that way too. So if you look at the size of the QEW, it's an incredible piece of land. It's 1,300 hectares that stretches, which is about the same size as what you might call downtown Toronto, between Bloor and the lake and Bathurst and Don Valley. And so right now there's about 200,000 people living in that area. So a second idea we had coming out of the shred was that we shouldn't be building just a transportation system. Like, why are we always obsessed, and this whole show is obsessed with mobility. All the newspapers are worried about us getting around and congestion and mobility. But one of the big challenges really of making cities is proximity, and it's not mobility at all. It's reducing trips. And so we thought, well, why don't we take a linear city model, which is a classic city planning model that is very rarely implemented, but which is meaning you stretch your city along a corridor of transportation, and you put the density right near your main infrastructure. So it's like taking the centralized train station, but just spreading it along the whole corridor. So that was the second idea we had. And then the other one was how to generate energy using that extra land that we've been given with the land that's been freed up along the highway corridor. And so we looked at a whole bunch of technologies. Like one of the ones that was suggested to us is there's generators that you put on the roads, so the car runs over it, and it makes a little energy every time it depresses the like this is good for speed bumps, not as good for highways. So we looked at a whole bunch of different technologies, and we came up with solar and wind being probably the two best to use, and geothermal as well, and geothermal. So this is a little detail of the PRT. So you can see it hangs there from a rail that's maglev, and it has different sizes. You can have different sizes or different numbers of people, and you can also have freight. We were assuming that the heavy freight will still run along the old rail corridors, but that it would be really great for like small freight and couriers and things like that. And for energy generation, we looked at the big, we already have big windmills along highways, and they have them everywhere, but people are complaining that they make them sick. So we were looking at different technologies that can still generate wind technology, and one of them is this wand that waves in the wind like seaweed, and it generates energy by the movement at the base. And the other one, it's kind of combination of, these are all ideas other people have had. We're trying to make a whole system here, so we're picking and choosing from the best stuff that we're seeing on the web and around the world. And the other one, we made a combination of a couple other people's ideas. And one is it's to do a solar panel using solar fabrics. They make basically solar sails, but they're also wind generators because this sail is in tension, and the fluttering of the fabric is generating motion energy at the ends. So we're trying to make a system that looks beautiful, that when you're near it is nice. It will not have blades fall off and run into cars and things like that, and won't make people sick. Then within the multi-mobility, all the different connections, we have a whole series of station designs to show how this thing could fit in with all the different ways of getting around, right from kayaking all the way up to buses and things. So this is some of the technologies that we were looking at that are nascent and being built. This is the one on the left is a PRT that's working at Heathrow, and so it works very much like the elevator system. You just go where you want, and it's a ground-based PRT. We picked the rail, like the hanging PRT system, because it's supposedly better for snow, which you can see in the picture next to the one at Heathrow, which is in Sweden, having some challenge with the snow. This is a invention to think about doing vertical turbines along the highway, which I think would work very well with the cars going both directions as well, and the real mills that we see around. This is a nice one from Essex County. We were looking all over geothermal and highways, and we found out that they're doing it right here in Ontario. They're using the geothermal to warm the surface of the road on the bridge, so that the bridge doesn't ice up. And it's almost a zero energy solution to ice up a bridge, and it's done right there in Essex County. And then on the right is a large solar array above a highway, or it's a railroad, above a railroad beside a highway in Belgium. And then a great example, local example, a modernist project is the Ville Marie in Montreal, which has buildings directly over top of the highway. So this is some of the things that we were thinking about, like connecting the building density directly with the new network of transportation. Oh, and I missed the other one. And the one on the right is it's a theoretical project about vertical gardening along the sides of highways. So this is some pictures of the final solution in 2040 or beyond. And it's showing, at this point, the highway is totally gone, and you get this bucolic landscape where people are flying past you at 200 kilometers an hour. And the wind is being generated in a nice motion above. It's great. And then here's the dense part where you're coming into a part of the linear city, and you can come straight in. It's all electric based. The PRTs, you just zoom right into your building, get right out, and you're already at work. And this is another one showing the gardener using existing structure and just hanging the PRT off it and building it right in, and showing how the transformation can happen, and the intermodal connection. So it's actually right there. You're right at your public square as soon as you get to the city. So this is our idea about how it could be phased. This is existing. You can see that all you really have is asphalt and sun and noise. And then in the first phase, we're putting solar panels along the noise walls, and we're putting in some of the energy generating poles. Put some electric vehicle, high occupancy vehicles in there, some BRTs in there. So we're trying to get people used to using electric, get people used to riding on transit. And then over time, you can start taking lanes out as soon as you put the first PRTs in, and slowly transform the highway over to the complete final solution where you get to live and work and travel 200 kilometers all in one place. That's it. Thank you.
Chris, I probably don't need it. Chris, thank you very much. We're going to put you on the spot now. Let our panelists ask some questions. Is this on? There we go. Now we have it working. And Henry, thank you very much for joining us. I know you sprinted to get down here, but thank you very much for joining us. Shall we say ladies first for the first question?
Sure. Why not? Well, thank you. That's fascinating. I have to say, maybe it dates me, but all I could think of when you were talking about the pods, the personal transportation, is George Jetson, who I think he transported that way in the 70s. So I had some questions around the energy generation, and if you did you do some calculations of really how much energy you could get from that kind of system? I mean, I assume it's small.
From which part?
From the wind and solar that you propose along the corridor.
Yeah, sorry. We did do the calculations. I don't have all the numbers with me.
Okay,
but,
so
yeah.
was it sort of like a 5% or 10%? Do you have sort of a sense of the order of magnitude, what you could get?
10% of the energy it would take to run the vehicles?
Yeah, yeah.
It would be very small.
Very small, yeah, that's what I figured. And then the other question I had is just around some of the costing, and was there any thought put into the sort of the cost of the implementation?
No,
of this kind of
there was
system?
no thought to cost other than we would try to keep it efficient unto itself.
Right.
But almost all the technologies we're looking at are nascent. Like there's
Right.
it would be almost impossible to
Right.
Yeah.
Okay, thanks. It's a very, very interesting proposal.
I have a question around that. And there were lots of things I liked about it. I mean, I liked the fact that you kind of started out by saying, well, we're not going to go zero energy. We're going to minimize one thing and maximize another. And, you started with a very pragmatic kind of approach. It would have been nice to build in some pragmatics about cost as well, because you, as a designer, to acknowledge constraints right out of the gate is really good to see. The engineer in me was very happy. I have a question about how the pods work, right? So you have at one bookend, you have a train. So it leaves on the hour, takes 200 people, goes from one station to another station. At the other extreme, you have these pods that go anywhere, right? I get in, it leaves, it disappears into the sky, and it takes me home. Somewhere in between the two is the solution, I take it. because it's not an electron. There's multiplexing issues, right? You've got to stream everything and so on. I never really understood where it sat in the middle, right? So the Heathrow example, they're just individual seats. I mean, it just means I don't have anybody else beside me who smells of garlic. But it's a train, really. So where does that settle in the middle, from the massive network to the simple network? How does that, did you?
Yeah, I'm not going to totally defend the PRT. In fact, I would be very honest and to say I don't totally buy it. But from what I do understand of it, the efficiency comes when they group up. So the inefficiency is the front surface of the car, which presents the friction, right? So one pod at a time is the least efficient way to travel, right? And a train has only one front, so it's the most efficient. So the PRTs, because it's computer controlled and because there's many ways in and on, right? When there's enough density, they group up together and they're all going down and operating basically as one train, right? So for sure, like at 3 in the morning, you're not going to get that efficiency, you know, like there's going to be always these inefficient times. And there's other issues that come up with it, and which is why we thought the corridor version in many ways is better than this kind of massive network version, is that where do you put all the cars when they're not being used, right? There's a kind of a parking problem that comes along with it too. And they could end up anywhere, like the Bixies, right? They could just end up anywhere. So how do you redistribute if people don't all go back the way, like where they came from, right? So there's all these kind of problems with that, which my guess would be that you have a lot of extra rail, right? Because they're all on these rails, or you need to have a big parking lot, a big structure where they all go home to rest in this kind of like that. So that part of it is there's some of the challenges that we came up with, but definitely the energy efficiency model of it is the interesting part of it. Like the maglev, and they're light vehicles, right? There's a lot of other efficiencies over trains, right? I'll give you another example. We were also looking at there's a whole bunch of different versions of this. Like we were trying to figure out, well, how could people get home using the same system? And there are a couple of solutions that some proposals, the cars come off the rail and they have wheels, and then you just drive home like a car, right? But the problem with that is you're carrying the engine with you when you're flying through the air at 200 kilometers an hour, so that's super inefficient. Mm-hmm. And then there's another version where somebody tried to fix that out, which they split the pod from the cart. So the pod is on the rail going fast, comes off, drops on a cart that houses your engine, your little engine, to drive home with. But then you have to park all those little carts somewhere waiting for the pods to come home.
Yeah, I'm imagining the logistical arm of FedEx would have a lot of fun with some of those questions. What I think is really neat, though, like to sort of, you know, I understand that this is a really futuristic vision and there's some really neat stuff in there, and there's aesthetics, which is, you know, I have questions about piezoelectrics. But so there's this final vision, which is really neat. You're aiming for there, which is sci-fi and interesting, and there's lots of lessons. What would be really great if you could extract out of that, though, some really practical, like 2 ideas that I really like. One is get the thing in the air, right? So you can reclaim the ground. I mean, that's just ding, why, you know. So you claim that as kind of a fundamental piece that comes out of all that extra stuff. And the other is that idea of the efficiency. So there's software now that trucks and cars will go behind each other on the highway. They'll lock in and they'll save lots of fuel. So, I mean, those are 2 really core ideas that can be extracted from this vision that I think you've given a really great context for. And it'd be great to see those pulled out.
Just one comment, and it's a question that I've been thinking about in your presentation. I mean, I guess, and first, you know, I'd like to say that, you know, I think it's great work, and, you know, the proposal stirs the kind of latent utopian in me. At the same time, it raises a number of questions. Obviously, cost and economics come into it. You guys are somewhat liberated from that based on the brief, I guess. It raises a whole series of questions about urbanism, which concern me, primarily because of maybe some implied redundancies. And one of the things, as much as there's a kind of implied elegance to the scheme, there's also a highly kind of editorial nature to this. And you know, one of the things I was thinking about was just how many cars every day are on the Gardner on a typical rush hour, right? I don't know if you know the number or have a ballpark, but let's put it in the Tens of thousands?
Oh, yeah, it's hundreds of thousands.
Okay.
Yeah.
And many of those cars are not individually occupied, right? So we're talking about moving hundreds of thousands of people, or let's put a number at 100,000. So we're not talking about 100,000 of these pods flying over the city, which may or may not be feasible. I'm thinking about all the infrastructure on an urban scale that would be necessary to get 100,000 people in, out, up, and down. And it's the up and down, actually, that is the kind of blurriest in the scheme at the moment. Even in the diagrams where there are kind of station designs, the up and down is a kind of dotted line. But when you think about people, and you have it mostly rendered as stairs, but there are weather issues. There are people who, have issues getting up and down, in terms of accessibility and so forth. There would be probably, by law, I'm guessing, an elevator at least in every one of these stations. All of a sudden, some of the energy numbers now skew radically towards inefficiencies and maybe redundancies. The other question I had, and I'm not sure if you covered it, is around the GO network and whether that is also replaced under this model or could be, and then what happens from an urbanistic standpoint to all of that land. It would seem to work within the kind of linear city model, but if this model truly by 2040 flourishes, you've liberated quite a lot of space, and then the question is, from an urbanistic standpoint, what happens there? How can that be redeveloped? What's it for? One thing that was particularly interesting to me, and I think that could be explored further, is can you do more with the infrastructure? Now, let's say, all right, we've made the numbers work. It's going to be beautiful. These rails over the city are an elegant, expression of a kind of 21st century metropolis. Like, we love it. It seems like this, once you make the investment in that infrastructure, it could do more. And a really dumb example, and probably not the most popular one, but it was implied by the FedEx thing, is the integration of services, advertising, media, et cetera. Once you have this infrastructure, what more could you do with it? Because it is not as single channel as the Gardner is now, but it's also not doing several things simultaneously. So what more could it do, both for the commuters, but also for the city? I don't know if you have an answer for that.
Yeah, I mean, for the most part, I agree with most of what you said. I think that these urban. Anytime you go up in the air with urban propositions, you get this dilemma of where is your public space? Is it the ground or is it the second floor? In Hong Kong, it seems to work, but most places it's challenging to do that. You make a kind of secondary public place, right? And definitely you would need elevators. But I think and we did think we had some. For other uses, we had some other things like running network cables along. It would be a really great internet connection place. And
yeah, there could be the fiber optic grid.
And we have animal habitat built into some. There's a whole bunch of little things that are on the panels that I didn't mention. And the other is geothermal. I didn't mention that in the talk, but we had geothermal across the whole ground that will then help heat and cool the buildings, because it's often very hard to get that amount of geothermal space in dense cities, so you have that available right now before you start building on it again. So that was another kind of multiple system that we were thinking about.
I mean, it's really just a last word on economics, and I'm not an economist, but on one hand, you can imagine the sheer number of jobs that are created for building this thing. At the same time, you think about the residential market and how real estate would become radically skewed for access along this linear corridor. And so all of a sudden it throws a whole series of things that had been relatively stable and predictable from an economic standpoint into kind of like a complete disarray, which is interesting. Yeah.
So if I could ask a clarification, what was the brief? Was there a necessity for it to be a kind of, Prada utopian vision imagination stuff, or was it just take the carbon out of the transportation system?
It was just the highway.
So playing devil's advocate, I would be neat to see sort of something play against this and just say, well, what would happen if you, like, I'm a fan of low-tech practical stuff, and just say, pass a regulation that makes every car get the same mileage as they get in downtown Paris, make them all hybrids so there's an electric battery in there, probably lead acid, and maybe throw some giant geothermal electrical plants up near Barrie, and you're done, right? So I wonder if we don't constantly distract ourselves from real working solutions by building these wonderful utopic sort of visions, when it's actually, a regulation or two might do the trick, and maybe an expectation of a small car versus a Hummer in the psychology of the modern human would go a lot farther toward answering the brief, which is decarbon the road.
Yeah.
Not that I don't love this picture, but
I think you're totally right. But we actually, our first phase, and when we first did the shred, was very, very conservative like that. We had BRT electric and HOV lanes for electric cars and things like that. But I really think that, like, my argument, this is my point of view then, not the group's. Most of what I've said is I think a good summary of what the group said. But this is my point of view. It's really, the highways are unsustainable, like, as a thing. They weren't a good invention in the first place, and the kind of urban form that they create on either side of them is inefficient, and no matter how efficient your system gets, they will continue to be inefficient. So unless you rethink it, like, you have to rethink the brief. Like, and I would also say, we've built tons and tons of bad infrastructure for 200 years. So I think it's much more interesting to me, I think, as a Gen X, I would say that our generation deserves to make the same mistakes as our predecessors, but in order to save the world instead of wreck it. Like, I think that cities are constantly experiments, and what we usually are doing is trying to bandage them instead of rebuild them. And we've spent the last 50 years going, we made mistakes making highways, and now we have to solve things. No one will change their way of living, when in fact there's a better way of living. It just hasn't been built yet. And in fact, if everything we do is building towards a vision, as opposed to just how do we get around or sell more tires or sell more gas, like, there's a new future out there. And it may not even be this one. It may be that we compact our cities. I actually think a rail-based solution might be the solution, to go back to centric cities, to be honest. But and you could probably do a rail-based system using the urban model of this, a linear rail-based system. Maybe you could do. Yeah,
it's the original Soria-Mata
Yeah.
Ciudad Lineal is a rail-based system.
Yeah, but the problem is the trains don't stop and start as fast as PRT. If the PRT really works, it might be good. You know what we are going to hear the contrary argument to that is the Google car. So you'll hear it next. I'll let them present it. But it's the kind of competing future model of this. Yeah, is that the computer will drive our cars, and we will get that. What you just said, yeah.
Yeah, I don't have the benefit of seeing the entire presentation. I think I was actually involved in one of the charrettes when the first project was put together months ago, and it's sort of interesting to see the tail end of it. I don't know if this combined multiple charrettes into this one vision, which seems like this is a powered roadway. I'm guessing, because I see elements of various ideas here. I think it's a great mechanism to illustrate a lot of neat technologies, but how it all hangs together. I keep coming across the whole implementation and what's it all going to cost to pull it all together. I think you've got to somehow get from the existing infrastructure that we have in this world to a new infrastructure, and you can blame a certain generation. You know, a lot of this stuff was built when the planet had 2 or 3 billion people, and they thought, okay, it'll work till 5 or 6 billion people, and it's now at 7 billion and going to 9 or whatever. I think it was sort of designed within the world survived within the horizon of the design horizon, which for a lot of things was 30, 40, 50 years, and now we're 80, 90, 100 years into things like the electrical system, the sewage system, which is falling apart. But society just doesn't tend to design with that kind of horizon, and we're in a situation where, you know, infrastructure should have been rethought out before the wheels started falling off of it. And this should be a continuous exercise rather than moving along to when you get to a critical point with respect to climate change and all these other things where we're really pushing the envelope. Society isn't really doing something until it's really, really drastic, and that's sort of what's happening in the world. So, you know, I've been asked to comment on the specifics of this project, and unfortunately I didn't see the details leading up to it. I think I'd say yes, it's interesting to showcase some of these technologies, but I just don't see how we bridge from what we're doing today to that sort of vision and the fundamental economic cost drivers are the principal hurdles, like number one to getting there.
Can we take a shot at that?
I pretty much said everything that I thought, but I would just say that I agree. I think that there's a lot of metal in this thing, but I would argue that the rails lasted 200 years, right? The rails are a really good sustainable technology, and we are taking them out of our country like daily. Just take them Northland, they just canceled the Northern train. It's crazy. So I think that the rails, and this is a rail-based system, it will last longer than asphalt. That's pretty good. A lot of metal in it. Maybe if you take all the metal out of people's cars and you put it into the thing, it might balance out. Maybe people live closer to the corridor and not so far out. Maybe. But I think that other than that, it's no more technology in it than everybody's car, which are getting fancier and fancier every day. So I don't think it's that crazy.
No, I know,
even
but
though I drew it.
yeah, no, I agree. There's core ideas in here that are actually really good. It just gets lost in this utopian vision. So, for example, you know, we have a mayor who poo-poos on streetcars because apparently you have to wait behind them every now and again. Well, move rapid transit into the air, right? And I think you could do a cost-benefit analysis of having hanging trains. They have them. This is not actually new. Mm-hmm. The train hangs and it goes over the city. And you look at the infrastructure cost of building support columns to have a train go over a set of buildings. There's probably a good cost-benefit analysis there, and it's based on the simple idea you have of get things up. And you're just making that real. You're saying, I'm going to put a train in the air, and I can do it. So I do think you're right. I think there are core facets of this thing that do work on an implementation strategy that takes into account existing infrastructure. It's an evolution as opposed to a revolution. And it takes us somewhere, and it takes us somewhere with infrastructure that does last 200 years, does take into account constraints on energy consumption and so on. So that's why I mean by to extract out of this fundamental principles that are ultimately timeless. Better use of three-dimensional space, you know, cost-benefit analysis of something that can take, you know, air three-dimensional space instead of ground three-dimensional space. Real estate's a premium down here. It's not up there in many places. So I think there are interesting repercussions you could draw out of this thing that do pass the test of pragmatism, cost-benefit, design, right? And that's the beauty of this thing, is that you've provoked those kinds of thoughts.
Yeah, the only additional thing that I was thinking that's really interesting, I mean, you ultimately suggest that the road goes back to nature one way or another. And actually, as seems crazy, but actually it has a lot of merit and value in that proposition. I love the idea of the higher train and the nature underneath, because actually part of the problem we're having in Southern Ontario is corridors for wildlife, right? Like that's a big issue in that's why we're losing so much of our wildlife, not because we don't have the areas, but they're patchy and they don't have a corridor. And so when you think of that, this would actually bring a lot of wildlife back into urban areas, which would be probably for some people a bit of a problem, but for many of us a real blessing.
I just have one last question around utopias, I guess. Who would be the authority that would build, maintain it? I mean, so now I'm not thinking as a transportation planner or an architect, but almost a social planner or government planner. Like, ideally, how would this work?
My understanding of transportation systems, As far as I can see, where it's going to be built by the private sector, and they're going to make a lot of money off it. And we don't have to worry about investing in transit in the very near future, because as soon as they get their location-aware stuff up to snuff, you're going to start seeing all this convergence happening, like octopus cards in Hong Kong, where you're getting benefits. You got a Groupon that says if you take your car today and park here and get onto the PRT, you're going to get $5 off, whatever. It's just going to all come together, and we won't have to worry about it anymore. They're going to know everything you do. You're going to get tax benefits for biking and walking, and it'll all come together into one complete mobility system. So I'm not really worried about it. I think it's probably 20, 30 years out, but I think it's time to start fighting with taxes and money and all these ridiculous things you hear in the paper, and start looking at much more creative ways of funding these things, because they're happening all over the world already, and we just need to bring them together and converge them. And the TTC's been trying to do a smart card for like 15 years. Like, forget about TTC has no funding to do infrastructure. They can't even run themselves like a business. They don't even know how to make money and how to capitalize. They don't even know how to sell Spacing can sell t-shirts, and TTC can't. Like, that's ridiculous. So that's why the private sector will take over. They will just blow them away. And you'll see it, like Viva. Viva is the best bus system in the GTA, because they know. And when they came in, we worked a little bit on that plan. They said, we want this much density at all our stations, because we need to make our investment back. What public authority can do that? They can't, because the ratepayers will fight them. So they can't even build intelligent transportation systems, because they can't supply the actual people in the right place to use them, right? It's a complete rethinking of how you design your cities.
Well, the public transport system has a mandate to serve lots of people. They can't just pick off the low-hanging fruit and say, I'm going to serve those 8 stations and not those 30. So, to be fair, Viva has an advantage, right?
It's land use plan. The problem with the modern project was they split everything into silos. And then now we've discovered mixed-use planning again, but they haven't brought all the systems back out of their silos and mixed them up again. So everybody is operating like they're running only one thing. And so you need the social housing department to be the same as the TRCA, to be the same as the TTC. They need to be one organization that can actually manage their land and the way people to get together, get around between those land uses in an efficient way. Like the Places to Grow plan did not take into account employment uses. So we have all these huge employment areas that nobody can get to, where we're densifying our suburbs, right? It makes no sense, right? So these guys are like 30 years behind in thinking. Like, don't get me wrong, I know it takes a long time for organizations to change, but that's the future. It just has to happen. Yeah.
Well, I think, Chris, thank you very much.
Thanks.